Alright, ladies and gentlemen, welcome back. We got the last two problems on here. This is part 3 of area ratios for similar figures. So as you look at this, you're looking for similarity on here. Right now nothing's similar because you don't know whether any of the angles are congruent on here, so I'm going to add on a couple arrows. Parallel lines means you've got corresponding congruent angles here and here, or you could say a shared angle down here. Big triangle and that triangle 1 share that angle, which kind of answers this question. Why are the triangles similar? Well, you got angle-angle similarity postulate because of the parallel lines and the corresponding angles. So that's sort of the proof behind why this works in terms of the similarity. Again, I'm using area 1, and then this pink area here, or purple area, is area 2. That's a Roman numeral 2 and a Roman numeral 1 to allow you to answer these two questions. First one's asking you to compare the similar triangles. To compare similar areas, you first find a scale factor. So 3 in the small triangle corresponds to the base of the big triangle. That's a 3 to 5 ratio. Hopefully by now in this little presentation that makes sense. It's kind of easy for you. A lot of people will write that down here. It's a 3 to 5 ratio for the areas. No, not quite. You've still got to do something with the scale factor to get the area ratio. Hopefully you quickly go, oh yeah, I square that, and it's a 9 to 25 ratio. And I'm hoping this makes sense. If you think of this, this is saying that the small triangle is, it's about 1/3. 9 to 27 would be a third. This is about a third of the entire thing, which would mean that this is sort of 2/3 of the entire thing. Triangle space 2 is almost like 2/3. And look at it visually. Kind of looks like 2/3 of the space, and this kind of looks like 1/3 of the space. So that should kind of make sense. And if I keep using those ratios, if this is sort of 1/3 and this is sort of 2/3, this is almost a 1 to 2 ratio in terms of space. This is almost twice as big as this one, which is what I'm looking for in this one here. So area 2 is going to be compared to area 1 on the second one here. You're no longer using similarity because you got a trapezoid compared to a triangle. You're using the area addition postulate. Think of these as actual areas for a minute. If this entire space was 25, and this one's 9, this is 25, this is 9, how much would that leave for area 2? And hopefully you're going to do the math, either in your head or with the calculator quickly. 25 minus 9 gets you the area for just this space here. The big triangle, subtract out this space, and you get 16, hopefully for that. So that is a 16, and of course area 1, we're still calling that sort of a 9, area of 9 on there. It's a 16 to 9 ratio. I am hoping at this point you really get your head around this. You get your idea of what that is. That's important. This is, like I said before earlier in this thing, it's the type of question I would put on a test. You can find scale factors, you can find area ratios, you can find perimeter ratios, which I didn't have up here, but you can also go one step further in this chapter where you can use area addition postulate embedded into a similarity problem. So hopefully the last one on here is easier for you at this point. A lot of numbers to add onto your drawing. If you go around in a counterclockwise fashion, this is ratios are my labels. R-A-T across the bottom, I, O, and S. One important piece of given information, AITO is a parallelogram. So this is given. Don't overlook that. This shape is a parallelogram. Excuse me. So you've got triangles. You've got another big triangle here. You've got a trapezoid right here, which some of you might overlook. This is a trapezoid because these are parallel. And you've got 3 ratios to find. I'm not sure why they don't come up here. They're on your handout, your paper. You may want to pause this and work through it. It's a little tricky. You got the side length of 4, a side length of 7, and a side length of 6 to work with, and you do not need any more information on this one. So be careful how you read this. This is triangle RAS to triangle IOS. See if you can determine the area ratio for those two. And of course there's vertical angles here. There's alternate interior angles here. So you know these two triangles are going to be similar. The only thing that corresponds is the 4 corresponds to the 7. They're kind of flipped around. The bases are flipped around. So a lot of people will write, oh, it's a 4 to 7 ratio. Hopefully don't fall into that trap. It's not a 4 to 7 ratio. it's that scale factor squared. So it's actually a 16 to 49 ratio. And if you haven't paused yet, this is a time in class where I pause for probably a good 5 minutes and let people really work through this. If you really want to get the hang of it, try it on your own, come back to it here, and then check your answers. RIT is the big triangle. I'm comparing that one to RSA. So big triangle compared with the small triangle. I saw a lot of people try to compare the 4 to the 6 in this case. Well, they're not even corresponding parts. Think about what this 4 corresponds to. The base, maybe I'll call this one the base. What's the base RT? How long is that? And hopefully you come up with 11. So a lot of people will use that 11 and they'll use the 4 and they'll call this 11 to 4 ratio. Again, those people forgot to square these ratios. This is a much bigger ratio than 11 to 4. It's actually 121 to 16. And then the third one on here, I don't think I put the word trapezoid on your paper, but SATI, that little quadrilateral, is a trapezoid. So this is no longer similarity. This is using the area addition postulate and really using these values here. If this is a 121 to 16 ratio, think about how much that leaves for the trapezoid. So again, this whole thing is 121. 16 represents the little triangle. How much does that leave for this space? And hopefully you come up with 105 by subtracting those spaces on there. Again, I'm subtracting the big triangle minus the smaller triangle to get that trapezoid. And that's your last step on there. A 16 to 105 ratio. So hopefully that makes sense. Again, this is the type of question you'll see on a test. 3 levels of it. One level being scale factors, which is sort of implied in here. Area ratios, which are squared. And then the last step of this is using the area addition or subtraction postulate to get something a little more challenging, a little more complicated on there. There is a worksheet that goes with this. If you haven't got that, if you're a junior and you haven't got that, or if you're absent, come in and get that as soon as possible. It does say worksheet 9.5 on it. It's good practice for the quiz. Good luck, and we'll see you shortly. Thanks.